Hi guys, my name is Emmanuel Jauge. In this video, I'll be showing you how to prove some identities in trigonometry section. Please have a pen, have a notebook so that you can take notes from this series, and please don't forget to subscribe the channel. Now I want us to read what we have here so that you can prove it in the autonomous sense. We are saying prove that sine of 3x over sine x minus cos of 3x over cos x is equals to positive 2. Now, I always advise my students to check the side that is more complex than the other and prove from that side. In our case, we have the left hand side, and you're also going to have the right hand side, that side of 2. And then now you're going to compare which side is more complex than the other. In our case, this side of the left appears to be more complex than the right hand side. For an example, you can't prove that 2 is equals to the whole of that side. It's highly impossible unless if you are capable. But now I want us to prove this identity from the left hand side and get that 2. Now I'm going to write a proof. So I'll be proving this identity from the left, don't forget that. So I'm going to write the left hand side. I'm going to copy it, which is going to be sine of 3x over sine of x minus cos of 3x divided by cos of x. What I will then do is I'm going to take the LCD of this expression, and then which I'm going to assume that everyone understands what is LCD. LCD simply means the lowest common denominator, which in our case is what? It's sine cos x. So I'm going to write sine x multiplied by cos x in that case. So now I'm going to say how many times does sine x goes into our denominator or into our LCD. So it goes into cos x times sine 3x. So this is going to be a cos. It's going to be a cos of x multiplied by a sine of 3x minus. Now I'm going to see how many times does a cos gets into our LCD. It goes into sine x times cos 3x. So I'm going to have a sine of x multiplied by a cos of 3x. Let me enlarge my division right there. So then now I'm going to say to myself, the numerator appears to be an identity, which I call it the compound angle of what of sine. I guess it's sine, because one can say, well, that is going to be the written as, I'm just going to put it nicely, it's the same as a sine of a 3x multiplied by cos x. I'm just reversing the order of the expression, and then a minus, and then I'm gonna have a cos of a 3x multiplied by a sine of x. The same thing here, I'm reversing the expression. Why am I doing that? Because we have let me just write it down, this one. It's going to be sine of x times a cos of x. Now pay attention, we have a law that says that a sine of a minus b equals to a sine of a times a cos of b minus a cos of a times what? Times a sine of b, which is exactly what we have in the numerator if you are to pay attention largely. So I'm going to convert my numerator to be in this form, where my a is 3x and my b is x itself there. So let us apply that law. We are going to have in the numerator, we are going to have a sine of what? Of a 3x minus x in that case, divided by what? By sine x times a cos x. And then now I'm going to have a sine in the numerator, what is 3x minus x is just 2x, so I'm gonna have that divided by sine of x times cos x. And then now I'm going to apply the numerator. It's a compound and it's a double angle identity of what of sine, which is going to give us what? It's going to give us a 2 sine of x times a cos of x divided by sine of x times what? Times cos of x. And then now you can simplify it for yourself. You will see that this cancel with that, and then that cancel with that, and then you're basically left with a positive 2. And then now if you compare and check the side which we're proving here, we're proving that the left hand side must give you a positive 2, which indeed it gives you positive 2. So you must write that which is the right hand side. So you've proven from the left that it gives you the value of 2, which was the right there. So this is how you guys will solve that. Thank you very much for watching.